A rocket engine burns fuel hot enough to melt steel, using steel to contain it. So why doesn't it melt? By the end of this video, you'll understand how something the size of a car generates more power than a nuclear submarine, and does it in total silence of space, where there's no air to push against. A rocket has one job: throw mass out the back, fast enough that Newton's third law pushes it forward. That's it. No air needed, no wheels, no wings, just controlled violence. But here's the challenge. To get that mass moving fast enough to escape Earth's gravity, you need combustion happening at temperatures around 3,300 degrees Celsius. That's hotter than the melting point of the metal the engine is made of. Inside the combustion chamber, fuel and oxidizer are injected and ignited. On Earth, engines burn fuel using oxygen from the air. In space, there is no air, so rockets carry their own oxidizer, usually liquid oxygen, mixed with fuel like kerosene or liquid hydrogen. This mixture doesn't just burn, it detonates in a controlled, continuous explosion, producing gas at pressures over 200 times atmospheric pressure. So how does the chamber survive? Regenerative cooling. Before the fuel is burned, it's pumped through tiny channels in the chamber walls, literally cooling the metal from the outside while it's being blasted from the inside. The fuel absorbs the heat, then gets injected and burned anyway. Nothing goes to waste. The hot gas needs somewhere to go, and this is where the nozzle comes in. That distinctive bell shape isn't for looks. As gas rushes through the narrow throat of the nozzle, it accelerates to supersonic speeds. Then, as it expands through the bell, it accelerates even further. Some engines push exhaust out at speeds over 4,500 meters per second. That's 13 times the speed of sound. All that mass, moving that fast out the back of the engine, creates thrust. Newton's third law: every action has an equal and opposite reaction. Push gas out at thousands of meters per second, and the rocket gets pushed forward with equal force. A single Raptor engine, like the ones on SpaceX's Starship, produces over 2 million newtons of thrust, enough to lift roughly 200 tons. Here's what makes rocket engines one of the hardest machines humans have ever built. They have to survive extreme heat, extreme pressure, and violent vibration for minutes, while pumping propellant fast enough to drain an Olympic pool in under a minute. One tiny flaw in a weld, a valve, or a turbopump blade, and the whole engine can tear itself apart in milliseconds. That's how a rocket engine turns liquid fuel into millions of pounds of force, enough to break free of Earth's gravity itself. If this broke down something you always wondered about, hit like and subscribe. It genuinely helps this channel grow. And tell me what engineering concept you would love to understand next. See you in the next one.